Okay, so the two remote sensing platforms or files that we'll be looking at today is TAMSAT and LandSat. TAMSAT and LandSat. So we'll quickly look at how to get those files because they are platforms for you to obtain these files, and there are also platforms for you to how you modify the files and process them for whatever thing you need to use them for, and that is what GIS does basically. So we'll see where to download TAMSAT to start with. So we have this tamsat.org.uk. Now, TAMSAT, if you check the full meaning, it has to do with tropical rainfall in Africa, tropical rainfall in Africa. I'm trying to see if I could quickly see the full meaning if it is given on their website here. But that is what it's about. TAMSAT basically provides you with rainfall data. So I would teach you on how to download the data that you need for whatever thing it is you want to do. And I would also teach you on how to process it to get your rainfall values. Because by downloading it alone, you don't have the values. So you'd have to process the values before you're able to make sense of whatever satellite image or satellite data that you get. So this is TAMSAT. Can we confirm that we are still together? Anybody, please? Anybody? All right. So would basically go to download data because we want to download data basically from TAMSAT. And I said earlier, the kind of data you find, you can see the coverage is for Africa. So the kind of data you find is rainfall coverage within Africa for a particular period of time. It doesn't have to be recent. It could be based on the data that is available, maybe from time past. So we look at the following options that are here. You have data download when you want to get individual files. This is for time series data. This is zipped file by year if you want to get it by year, and however it is you want to get it. So I would just use this as an example. Data download. So that is when you want to download individual files. So this is what the interface looks like. You have rainfall estimates, you have a couple of functions here that you select from, and then it shows you what the map looks like here. Yeah, it shows you what the map looks like here. So we'll quickly try a download. This is the version that is available on TAMSAT, version 3.1. It's the latest version. There was a time it was just 2.0, there was a time it was 3.0, but this is 3.1, and you need to determine what you want to get. If the data you want to get is daily, if you want to get it pentadal anomalies, maybe you want to get it decadal, that's for like 10 years, and you want to get it for monthly, you want to get it seasonally, you can select any of this. But be careful that whatever it is you select, for instance, I get to select monthly. Now, if you get to select monthly, TAMSAT provides you a whole lot of directory that you can go through beyond this data download page, explore it, and it will tell you what all of these terms mean. So if you're downloading the data monthly, it will tell you what downloading it monthly means. Are you downloading it as an average for the month, or you're downloading it as the first value recorded for the month? But in this case, it is the average for the month. And the way it is done in TAMSAT is if I, for this particular one, because I'm familiar with using it, if I click on a particular year, say 1990, and I want to download the file for January. Now, I wouldn't select one because the file for January is made available in February. So I would rather select two. Understand now? So this is just representing the distribution of rainfall for January because they calculate the average at the end of that month. So the average for January is given at February, the average for February is given at March, and it continues like that. So you're able to do your download here, having selected it. Mind you, it will display a map for you. So you're able to see that, okay, indeed, there is data that is available for rainfall within Africa at this particular time. 1990 for January. But then let me just quickly try out something. When you click on a year like 1984, it also shows you that there is data for 1984. But when you click on 1983, it also shows that there is data for this month. Let's click, okay, way back then. Now you can see that, of course, this is supposed to represent December of 1982, because like I said earlier, the summary will be documented in the following year. So this is not available. That is to tell you that there is no data for 1992 December available, and that is why you see this place being blank. So we go back to the data we want to use, say data for 1990, and then it gives us this. Then you click on download, and you click on download, it takes you to wherever it is you want to save it. And all you just need to do is look for a directory that fits in, and then you save. But in this case, I won't be saving it. I just needed to show us how to download it. I have a couple of files that I've downloaded in this regard, so there will be no point me downloading again. So I'll try to look at this. Permit me. Show. So we are familiar with how to download. Without even wasting time, I don't have to show where the file is. I could just go back to this. Let me excuse this from here. So I have a blank page. Now I have downloaded my data. Okay, I think I would need to show you the downloaded data, so it won't look like so that you see what the data would look like. So this is my downloaded data for rainfall as gotten from TAMSAT. So this is what it looks like. Perhaps if I should expand it, this is what it looks like. You download one after the other. For instance, I started from 1999. Now, the fact that it is O2 means that it is for January. This is January 1999 average. This is for February 1999 average. I downloaded them one after the other. It depends on how you want to download. You can download in batch, you can download in layer, you can download per year, you can download time series. All you need to do is just know the exact file you want and then download it as such. So this is my data now, and this is the folder I have it in. All I need to do now to try to process this rainfall data according to suit my taste is me going to ArcGIS. I go to Arc Toolbox. Now I want to bring this data into my field, into my workspace. Unlike the way we used to add data from this portion, you don't add that kind of file. Now is known as a netcdf file. You can see that it has .nc. Rainfall file is usually a netcdf file. So you come here to multidimensional tool, and you yeah make netcdf raster layer. So you're going to convert this netcdf file to a raster layer. So we click here, and then we are going to fill in the variables. Can somebody confirm that we are still together, please? Okay. So I would impute my netcdf file, which I have just downloaded. I go to the folder where it's supposed to be. So it's here. And then I use this as an example. This is the average for January 1999. I would open it and see what it gives me. Mind you, when you impute it, it fills in all of this. Now this variable is automated from the download. RFE here means rainfall estimate. Of course, X dimension is your longitude, Y dimension is your latitude, and then would indicate this as RFE layer. But in this case, I might want to change it and label it as January 1999 so that I am more, I can be quite sure of what I just did. Click on OK and have it process it for me into whatever detail it is it wants to give me. So we could have this, hold on, it is still loading. Is David in class, please? Okay, so here it is. This is what Oh, okay, okay. So this is what the map looks like. It's a rainfall map of Africa, but then it is not exactly defined in the sense of it. But this is the rainfall map for Africa. Now, mind you, the net CDF gotten from TAMSAT is recorded in millimeters, like your rainfall. So this is there that the highest point here received 598 millimeters of rain that month, and this is the lowest, which is 0. So the blue portion, which is more like the Sahel and then the Sahara part of Africa, you can see that, of course, they didn't receive rain. That's another story. But you can see here we have comparatively high rainfall within this region for January 1999. So now this is for Africa. You might not exactly need rainfall parameter for Africa, or maybe you're working on something and you just need to show us the rainfall distribution for a particular location other than Africa. Maybe a particular location as small as, perhaps we use Ibadan. So I could say Ibadan. Let's try to see if we have a shapefile for Ibadan, and let's just bring it in. Say we are using just Ibadan, and yeah, so there is this Ibadan shapefile. All I just need to do is add it. So this is Ibadan shapefile. You can see how almost insignificant it is here, but it is what it is. That's the distribution for rainfall within that location. So we can actually extract the rainfall value from this map to just Ibadan alone, because that's our area of focus. So we can make a rainfall map for just Ibadan. All we need to do is part of the functions we have done before now, which is to extract. So we'll come over to this point. I think we go to spatial analysis tool, and then we extract by mask. Be reminded that your mask is Ibadan. So you're extracting by masks. You impute your raster, which is January 1999, and then you also impute your feature mask data, which is Ibadan. And all you have to do is select an output location and give it a name. Let's say we would have it, okay, let's add this output info. Okay, so let's put it in here. I would call it Ibadan Rains, and then we save, and then we process it. So what I am expecting that it gives to me is the map of Ibadan showing the rainfall distribution for the month of January in the year 1999, because that is the data we got, and we have been able to, we are trying to right now extract just Ibadan out of the entire Africa. And that is to tell you that whatever it is you're working on, whatever project it is you're working on, you can, within Africa, you can always get the data for the particular location once you have the shapefile. And of course, based on the lessons you've been taught so far, even if you don't have the shapefiles, you can always generate the shapefiles for yourself, be it points, be it polygon. You've been taught all of that. So whatever state, whatever country it is that you need to work on, you can always generate that. So now we have that of Ibadan. Let's see what it looks like. Let's remove this for now, and let's zoom in this and see what it looks like. You can as well do away with this and now see the distribution of what rainfall looks like in Ibadan within this time. To make it similar to what the original TAMSAT data looks like, we can come over here and tweak the, the gradient and make it from red to green, that kind of scale. We can do this, but then we would invert it. So there you go. You have the highest point up, you have the lowest point as 18. Now, interestingly, that is to tell you that even in Ibadan as of January 1999, the lowest point received 18 millimeters of rain, while the highest point received 43 millimeters of rain, according to this particular description. But then, interestingly, Of course, this is not the map we'll just submit as a map of rainfall. This is definitely just showing you how you can extract the values from the remotely sensed data that you acquired and make sense out of it. Now, from this value, I just extracted based on mask. I could also extract values, that is rainfall values, based on specific points. For instance, this is Ibadan. I also want to confirm uh, within Ibadan, maybe what's an example of a place within Ibadan? For instance, either Agbowo or Bodija or whatever location it is within Ibadan. Once I have a point feature, once I have a point feature, I can superimpose that point feature on this map and then use that point feature to generate or to extract the values of rainfalls. Now, what I'm trying to say is if I have Agbowo, Bodija, Mokola, Dugbe, and all of that as points distributed across this region, all I need to do is superimpose it on top of this particular map and then run some functions that will help me extract the values. The values that will be extracted will be point data. Now you can see this is a gradient telling you from low to the highest kind of rainfall received. But the value that will be generated in this other case will be what? Point data, precise values per location. And let's quickly check that. I want to confirm if I have some points features that I could use in this regard. I hope I have some points within Ibadan. Let me check, please. Okay, I don't have in this folder. Permit me to check another folder. Let me see if I can quickly do that. Uh, which of the folders? Which of the folder? Let me check this. Sorry. Let me have point features. Okay, I think I don't have here. Now let me check another location so that we can quickly do the extraction. Actually, that's what I'm particular about. Perhaps just add a folder. So maybe I should just use the opportunity to ask, based on what we've done so far, I mean, within this time in this particular class, in today's class precisely, any question, or are you trying to follow, or you're not following with your laptop, or you need some time to catch up with me? Or can you tell me what phase you are? Anybody, please? Okay, so you are not able to do it alone, right? Okay. Did you see the processes that would lead you to how to download the files? Okay, you can relate. You'll find the video, so you should be able to get you'll be able to get it. I'm trying to make us use a particular trying to see if I have points data actually that I would use to do the extraction. Okay, maybe I'll just add this particular folder first. Yeah. Sorry, is Olayemi following up? Are you doing it also while I'm doing it? Okay, okay, all right, okay, okay, okay. All right, awesome then. Okay, let me just see. There's this point feature here. I just hope that it is related to Ibadan. Let me just try it out and see. Okay, and I was roaming about since. So here we are together now, right? So here are some point features. Yeah. Now here are some point features that are concentrated within this part of Ibadan. So what we want to do right now is that we only had images and we processed the image from a much larger one, which is for Africa. We got out a much specific one, which is for Ibadan. Now, from this one that just showed the gradient across Ibadan, we are going to get even a more finite one, which is for all of these points. So we can just try to look at what these points look like by checking out the attribute table. Now, okay, this is showing different locations within Ibadan. Here you have, I think I can see filling station, Adeoyo Hospital. Let's broaden it, let's widen it, so that you're able to see how much data we have. So now these are different points. These are different points. But my major reason for using this data is not just because want to use it. One basically extract rainfall. So the rainfall data that I would extract, of course, would be to form another layer of your attribute table, but then it will be particular to each of these locations. It will be particular to filling station, it will be particular to this Adeoyo State Hospital and the likes. So without wasting much time, let's just run the process. So you come back here, since you've superimposed your point, you go back to your extraction tools. Now this is what you will do. Extract values to point. That is, you want to extract the value from your raster data to all of these points that are scattered within Ibadan. So we double click on this and we try to run the process. Now you input your point features. Of course, this is it, amenity. And sorry, it is delaying to respond, perhaps because of the size, or perhaps because there are different tabs that are open at the same time. Okay, now you input your raster, which is, now you can choose any of the above, either January or Ibadan, but since we're focusing on Ibadan, let's just do Ibadan rains, and then we select where this is going to go to, and outputs, but this time around we'll call it Ibadan points. All right, then we save, and let's see what it looks like. Processing the values to point. All right. So you can see here, you just acknowledge that it has been successful. Extract value to point has been successful. So we look at it here. This is it. Of course, you wouldn't see what the values are until you open the attribute table of that new data. Mind you, it was not the previous data, it's not the former one, but this new one that we just created. So you open the attribute table. It will still contain every other thing that was contained here before now, but the new feature that you would find is your rainfall as it should be. So you can see raster value. So we can as well move this and let's bring it somewhere here so it stay in front. So here you can see what this particular thing is trying to tell us, or what function, uh, the function that was carried out now tells us that at this particular filling station, 25 millimeters of rain was received at this particular location. Now, same with within Adeoyo State Hospital, 25 millimeters of rainfall was received. Same with Mobile Jogger Center, Mixed Bigs. Now, but for this location, 24 rather was received. For a location like this, 30 millimeters was received. You can see that it begins to show us the differences in the amount of rainfall received across those entire locations for that particular month in average. So we can see all of the distribution across the points that we had selected. So that is that when you want to extract different values to a point, it does that function for you. So you're able to see the rainfall that was received across that particular space. If we want to make it, if we want to do some more activities on it, let's just uncheck this, then check this, and zoom to layer. Now, this is for January 1999. How about if you want to construct a rainfall distributional pattern for a particular year and you have January? We can also obtain that for others. We go back like I would, that means I've downloaded all of my data actually. So I'm just going to bring them back into this particular workspace. So what would I do? Like I did earlier, you go to multi-dimensional tool and you make netcdf raster layer. Now when you do that, you impute your netcdf file from wherever it is, and in this case my netcdf file is where's the folder it was in again. Mm, let me just go back. Okay, so we should find the netcdf layer here. All right, and it's here. So the first one we selected was this, and that was for January. Now the next one that we would select here is definitely for February. We open it, we expect that it overlays it. So when it brings this particular point again, we know what to indicate, that this is for February 1999. That's all. We add it. One or more variables are invalid. How is that? Oh, sorry. I changed the wrong layer. So this will be February 1999. Then okay. Then gives you the distribution across Africa again, but this time around for February 1999. So of course here you have that of February 1999. Let's just try one more. We'll add another one. This time around we are adding for March. So go back there and select another. Uh, okay, sometimes it can be annoying to actually repeat these processes again and again. Okay, just for an example's sake, this is what we'll use just for March, and we'll do the extraction. We'll do for January, February, March. So the third one now is going to be for March, and that's 11904. So all we need to change is this and indicate that this is for March 1999, and you click on OK. So it does the whole processes for you. Now, you can repeat the same process if you want to overlay for different months or you want to overlay for different years, and depending on the data that you collect. So we have for January, we have for February, we have for March, and then we want to extract the values. So we go back again to run our extraction. This time around, mind you, we are clicking extract multi-values to point. That is, you are extracting multiple values to point. So you, oh, sorry about that. You're not using this yet. This is for a different purpose. So you use sample in this case. You use sample in this case. So you impute your raster, which of course, all of this, but you have to impute them one after the other. You impute for January. You go ahead again to also impute for February. You go ahead to impute for March. So if you have several years, for instance, or several months, for instance, from January to December for the year 1999, repeat the same process, impute all of it, then you now select your points feature, which of course is my word, amenity. Let's use amenity again, and then you click on your the location, the output location. Now the location is going to come out as a table. So let's just do this. Output feature, let's call it sample point, and then we save, and okay, let's run it. Okay, okay, so our table is loaded. We can of course open the table, and of course this is what our table looks like. Mind you, this is for this RFE, which is the first one, this which is the second one, this which is the third one. This is for January, this is for February, and this is for March. January, February, and March based on the extraction. So you could repeat the same process for every other month for the data you have actually collected. Bear that in mind. We just extracted rainfall data across locations within Ibadan. So you can do likewise if you have to produce the data for use, maybe for different reasons, perhaps for research, perhaps for whatever reason it might be, you're able to generate the data for such, and you're able to at different levels once you have your necessary files. So that is that for that is how far we are going to go with Rainfall and TAMSAT. I think so far we showed how to download the TAMSAT file, how to import it into the ArcGIS space, how we also manipulated it, extracted values, and also extracted by mask based on our locations. So you should be able to do that now. So the second part to it, I would show us how to download LandSat. So this is where we downloaded TAMSAT from. You can catch up in the video. Uh, Now we'll be trying to download LandSat. Where I used to download LandSat actually is Earth Explorer. So, and this is the website explorer.usgs.gov, and it takes you to where you can have access to different remotely sensed data, a whole lot of remotely sensed data actually. But for you to be able to download this data, you need to be registered or you need to have signed up with them. You can see that I am logged in already. I have an account with them. So you should be able to register with them, also create a profile with them, so you have access to different types of remotely sensed data. So first, to start with, we want to work on, because we've been dealing with Ibadan, we just continue our search. Uh, Now select a geocoding method. Okay, I want to get the place, or I want to get my satellite image based on address. I click on address. Now to impute it here, I decide to type Ibadan. And where is Ibadan? Nigeria. And I search. It shows me this. It shows me the latitude and it also shows me the longitude. So I select it because that is the location I want to work with. So you can see that the display on the screen here has changed and it is giving me Nigeria, and it is focused on Ibadan. So if I would download a particular satellite image, the coverage would actually be for this region. Mind you, the coverage is usually in parts and row. Parts and row is used to divide the entire globe, you understand now, into different portions. Now, for Ibadan, interestingly, it falls within the same pattern row actually. So we might not be able to talk much on that, but once you've selected the address, whatever file it is you download, you'll be able to find Ibadan within that location. So all you need to do right now from here is to proceed. Now the data that I want to download, what range? I could say maybe from uh, 1st of January year 2000 up until 1st of January year 2022. For 1 month, all of the months. Then I move on to data set, and then it begins to ask me. Now here is where you look at all the data sets available. You have aerial images, you have AVHR. Now, in my opinion, you should quite familiarize yourself with most of these remotely sensed data and what purposes they can serve. Depends on whatever it is you want to do. They are remotely sensed. They are available at different levels, at different scale. So if you want to find out more about it, you can do, of course, do your personal study to know how this data can be relevant to anything perhaps you want to do. But based on what we want to do today, we are considering LandSat. So sorry, so we are considering LandSat, and we have different types of LandSat based on their level and the products. So you have C2, you have level 2, you have C2 level 1, you have collection 1. This is much earlier, this is much early, this is relatively early, um, relatively late as of recent. So you could just click on. But then one thing I would also advise is that there is a manual for you that helps you understand LandSat better. You download the LandSat 7 manual or the LandSat 8 manual. It helps you understand how to process LandSat image into different things that you want to use it for. Perhaps for temperature, perhaps for vegetation, perhaps for land use, whatever it is, it helps you understand it better. So for these three, we most likely will just click on either of the two, either level 2 collection 2 or level 1 collection 2. So I can click on this. Mind you, once I click on that, it shows me that, okay, I've selected something and I can proceed. So I'll just click on that alone so that we don't have so much cluster of data. Then move on to additional criteria. Although I don't need to impute any additional criteria in this case, all of this product, L1, patch row, I am not actually interested. Let's just proceed to seeing the results. So it shows me an array of images that are available. Remember that I selected from the year 2000 up until the year 2022. So it shows me all images that are available within that time frame. Now, how do you know the date? Is by looking at the name. Here you can see that this photograph was actually taken between what, 1st of January 2022 and what, 23rd of January 2022. So here this is like, but most specifically this is the date, the 1st of January 2022. This data is available for this particular period. Now you can see here also this is available for 2021. This is available for 2021. This is for December 2021, 16th of December 2021. So it depends on what you want to do. For instance, you want to use, or you want to try to do a land use cover or land use land cover analysis, and you want to help us understand what it was like in the year 2000. So you wouldn't need a recent one. But if you want to compare, of course, you would need for 2022 and you would need for 2000, year 2000. So I would like us to maybe just, okay, since we are not downloading, let's just try out something, how to download. You look at these options. Here you have show footprint. Here you have browse overlay. This is another option for compare browse. This is for metadata, and this is for your download. Gives you different options when you want to download. Mind you, this is if you just want to download a JPEG. And of course, except you want to use your JPEG to, what's the word now? Except you want to use your JPEG or PNG to, why am I missing out the word? You want to digitize, you don't need GPNG or PNG. And of course, you are not digitizing remotely sensed data. What are you digitizing? So this is a JPEG showing you the natural color. You might just need this to just show you what it looks like. Now this is what can be relevant because it's a GeoTIFF data, is a thermal data also. But because of the purpose of this work, you're downloading the entire data, and LandSat can be quite heavy, particularly LandSat 8. Now you see that product options, LandSat collection 2, the product bundle. Now this bundle helps you to carry out different kind of analysis, from vegetation mapping to land cover to NDVI to temperature analysis, land surface temperature and light. So you click on this particular one, and once you have an account, it takes you to this place where you're able to download based on your preference. Once you click here, this is like the combination of all of these products, and you download. You can see the file is quite heavy, about 1.1 gigabyte. Here are all the products you will find. You find it at different bands: band 1, band 2, band 3, band 4, up until band 12. You have this. This is giving you information on the metadata, and all of those things are relevant because you will still be using them. So this is like in a text format. You open the file and you see different information. So it is important that if you want to carry out different form of analysis, when you are looking forward to downloading a Landsat image, you download the entire bundle. So all you need to do to download is by clicking this option. You would not have this option if you're not a registered member of the community. Once you register, you have access to downloading Landsat file. You click on this place, it takes you to where you want to save your file, and you save it as such. So I would just go to some Landsat file I downloaded one time. So I'll just show us what it can look like. Okay, so Landsat 8, which was downloaded. Yes, so this is what Landsat 8 could look like. Of course, it will come fully zipped. So this is it being zipped, but having emptied everything, you begin to see it as such. So you can see this is all of the files that would actually come with your download, and they are all relevant actually. From the bands to the text to the OVR files are very relevant. So it's always important, especially when you need to do a couple of things, to download all of the data. Now we'll go back to our GIS interface. This is for rainfall. We can quit this. Maybe I'll just save it before we quit. Mm, rainfall. Okay, So I'll save it here, and then we can open another file too. This time around, we are bringing in the LandSat data, and we want to explore what land use land cover may look like. So we are basically exploring land use land cover after now. So we are going to create a new from the ArcGIS, just open a new file. Yeah, blank. Let's just try to do something else. Now, please be reminded what I said we are doing is land use, land cover. Trying to show you the land use, trying to show you the land cover within a particular location. So I'm waiting for this to disappear so I can bring in my Landsat image. Right, so now we have it. So you import using the normal means. So you click on that selection and then you're able to import. So I will try to bring this in by clicking on this. Okay, yeah, so this is where it is. Now, for you to carry out land use, land cover analysis, you don't need all of the bands. You only need the bands from 1 to 7. That is band 1, 2, 3, 4, 5, 6, 7. And we are just going to highlight all of that now. You select them. For multiple selections, you use your control key. Select all of it, all of it. Yeah. So I have selected band. Confirm it. How do you know your bands? At the end of it, before the name of the file or before the file type, you will see B1, B2, B3, B4, B5. All of that basically identifies the type of band. Band 1, band 2. So you select from band 1 to band 7. Then you add it up and we'll see what it gives us. So interesting. This is what your remotely sensed data can actually look like. And this is the overlay of the bands. Now, because you want to do some analysis, in particular this time around, a land use land cover analysis to help you show the kind of what a particular land is used for, you would have to do a composite. And how do you do a composite? I just need to do is go to Windows, click on Windows, and go to image analysis. Once you select your image analysis, it would have brought into the tab here all of your files from band 1 to band 7. So what you need to do right now is select everything from band 1 down to the last band 7. So I have made sure that everything is highlighted. If you look through all of the bands are highlighted. Now what we are trying to do is we are trying to compress it. We're trying to compress the entire band. So we, having done that, you can see this feature here, which is composite bands. So we are making all of those bands a composite. It is what we get as a result that we now use to analyze the land use and land cover. So we make this a composite. Okay, so we've made this a composite, and that is what is relevant for our study or whatever it is we want to do. So we can, interestingly, remove this because we no longer need all of the bands. We only need the composite map right now. So this is the composite map. But because it was generated, we would have to save it. And like we have been taught earlier on, you go to data, you export data so that you save it as a layer for itself. Uh, let's see where it is going to be. Let me check if it is there. Okay, awesome. Then it's in the right place. Then we are just going to call it, we are going to give it a name and we'll call it land use. Okay, let's just put it like that. Then we save it. Yeah, so we save it and we'll see what it looks like. Then we can proceed from here. While we wait for it to save, are we still together, please? Is anybody on the call with me? Can you all hear me, please? Okay. Yeah, now it is taking a long time to save because, like you have seen, LandSat files are actually heavy, so it will take a while to process it, to save it, and that's why it's taking a while. It is only 25% done, so we would have to wait. We can't run past it. I will wait. Any questions so far, please? So I believe we understand it up until this point. So we are 60% done with saving. I'm sorry it is taking this long, but we have to wait actually. Like I said, Landsat files are actually big, so it can be a bit of a challenge. No, this is serious, but it should be downloading soon. Now I can only hope that we are not waiting till forever. Okay, I'm thinking of what I can possibly show you while we wait. Um, man, the earth is hard. Well, we've been like this for more than 10 minutes actually. Hope you respond soon. Is anybody trying to say anything? Sorry?